Okay, lesson on type 3 and type 4. These are both type 3. I'm going to do them separately, but save space and putting them next to each other. So remember, type 3 were binomials, two terms, no middle term. Okay, so you're going to make a copy, something times itself, and then you're going to have the signs being different. So very simple, right? You don't make this complicated. Don't overthink this. I need something times itself that makes 9. You can't put 9 in 1. All right, I understand that 9 times 1 is 9, but that is not a perfect square. That is the point of these. It's always something times itself. So now I have to make a 25y squared. Well, to make 25, 1, 2, 3, 4, 5, right? 5 squared. So it's 5 times 5, but you need to get the y squared. So just like always, you got to put the y and the y. Now, one of them has to get a plus, and one of them has to get a minus. They have to be opposites so that the middles cross out. In the middle here, I would get a positive 15y. And on the end, right, the inner and the outer, you get a negative 15y. They cross out. That's why there's no middle. That's why it's not a trinomial. That's why it's a binomial. So now the other problem, it's a little more complicated because it has more letter, but who cares? It doesn't change anything. I need a 49m squared. So I need something times itself. So it has to be 7m and 7m. Why 7 and 7? Because 7 and 7 make 49 when you multiply them. Now I need something times itself to make 4x squared. So you got to put 2x, 2x. It has to be something times itself. Now again, one of them gets a negative and one of them gets a positive. It doesn't matter which one you put first, as long as you make them different. All right, so something times itself with different signs. You're just making a copy. I mean, look, they look identical, except one of them has a minus, one of them has a plus. So that was type 3, difference of perfect squares. All right, poof, magically, type 4. So type 4 is called perfect square, not difference of perfect squares. Type 4 are trinomials, where the number in the front is a perfect square, and the number at the end is a perfect square. The middle number, you ignore. You don't look at this middle number. It's going to confuse the hell out of you. How do you get 40? You don't. You're going to build it, and then you're going to make sure the middle number comes out. Okay, so the important part of these is that perfect square here, and this is positive. If this was a -1, this would not be a perfect square. Something times itself with the same sign would not give you a negative at the end. You must have a positive there. So how you build this is really easy. Ignore this 16. There's no way you can multiply something by itself and make 1 and then add that up to 16. It doesn't work. So you ignore this. Don't look at it. Look here, 64. So it's got to be 8x and 8x, because that's the only way you're going to get 64, doing something times itself. And then to make a 1. Hello? 1 times 1 is 1. Now I need my signs. Whatever's in the middle, drop that dude down. He must be the same. Why? Because you have a plus here. A positive times a positive is a positive. Something times itself. Now, but how do you get 16? You don't get 16. This is nonsense and stupid. It doesn't make any sense. If you look at the inner and the outer, if you make your little foil rainbow, 8x in the middle, inner. 8x on the end, outer. 8 and 8 make 16 when you add them together. 8x plus 8x is 16x. The middle will take care of itself. If you build this properly, the middle is done. So it's all good to go. Now, as I said, if you want to write this in a more sophisticated way, which we will do later in the semester, you can write it as 8x plus 1 squared, right? This means that something times itself with the same sign. So you can write that. For now, if you don't want to, don't. You can leave it like this. This is perfect. All right. Now, the second one, it looks so nasty and it looks so complicated, but it's not. Perfect square in the front. Perfect square at the end, and it's positive. 40. Ignore the 40. I need 16x squared. Has to be 4x and 4x. Has to be. Like, but it could be 8x and 2x. That's not something times itself. You can't pick 8 and 2. It has to be something times itself. And 25, it has to be 5 and 5, and then you need y squared. So again, you put 5y, 5y. Now, what are the signs? Well, this one drops down, right? And this one must be the same as that one. A negative times a negative makes a positive, right? Done. Now, again, you want to be fancy and write it all sophisticated. Pow! 4x minus 5y squared means that. You don't want to write it, don't write it. Who gives a damn? You can leave the answer like this, all right? So something times itself, something times itself. Now, make sure the middle comes out, right? You have negative 5 times 4, which is negative 20, xy, alphabetical order. The outer, negative 20, xy, right? Negative 5 times 4, xy, alphabetical order. Minus 20 and minus 20 is not 0. Minus 20 and minus 20 is minus 40. So you get the number in the middle will take care of itself if you build it right. Just have faith that it will work. And you can check it at the end. I checked it. I made sure it works. I got negative 40. But I didn't use this when I factored. I don't look at the 40 as I'm factoring. I looked at the 16 and I looked at the 25. That's how I got my numbers. Okay, so that's type 4 perfect square polynomial.